All right, hello everyone. Welcome to today's demo session. Today we'll be covering TFROBOT. Go ahead and share some slides. So, demo session TFROBOT, July 22nd, 2024. Our agenda for today, we will show off where you can find information about TFROBOT in the manual. Give a short presentation here and demo and some discussion. So here's the manual link is here, probably the best way to find that information. Just go to manual.grid.tf and search for TFROBOT. You'll find some information about it. I won't actually step through that now, but I will show you a bit later where you can find TFROBOT code and executables I'll be using today. Here it is. This is TFGrid SDK Go repository on GitHub. And this is where TFROBOT lives. It's one of the tools that is developed as part of this mono repo. And TFROBOT is a command line tool that allows users to create large groups of VMs. You can also use it for small groups. It doesn't have to be large, but that's the idea, is to create groups of VMs on the ThreeFold grid, and you basically give it a template and it will find nodes that match your criteria, deploy VMs to these nodes. I'll be showing you more about how that works later. Some of the key features and benefits, if you would be under my box over here, this side. So again, create large groups of deployments. You can cancel them also very, very simply and both in one command. We can load the existing deployments, get the information back about the various VMs. The TFROBOT will also print and store in a file the information that we get back, things like the IP addresses that are assigned to them. So you can connect via SSH if you want to. And you create your configuration file in YAML. So it's a relatively simple config compared to something like Terraform. You can see an example here on the right. I'll go through that in more detail and show you an example file for the deployment that I will be creating today. Without further ado, let's get into that. So demo time.
How the fun begins.
Yeah.
Glad
As I
when
promised, here is another look at, this time in dark mode, a little easier on the eyes. Look at the SDK Go repository. If you come in here, TFROBOT is in here. This is where you can find basic information about how to use it. Of course, there's also the manual, like I mentioned before. All of our tools have some just basic documentation. Here's an example config file. That'll be the template for what I'm doing today. Some explanation about what the various parameters do and explanation about how to use it. So this is your digest all necessary info. And to use this tool, you'll need to either compile it or download the precompiled binaries from the release, which is the simpler and easier method. If you're on Linux, you can grab this Linux x86-64, or if you are in some Windows subsystem for Linux, Linux VM on a x86 system, that's Intel or AMD. If you happen to have an ARM system running Linux, or Windows subsystem for Linux, there's ARM here. For Mac, you have Apple Silicon, also ARM64, or Intel Max. So you just grab the archive that applies to you. Inside, you'll find all of the binaries, TFROBOT, TFCommand, and some others that you might not be as interested in, but they're all in there. You can download that, extract it, keep the ones you want, delete the rest. That's up to you. All right, so the demo that I will be showing today is something that I cooked up, been cooking up for a while, and what we're going to do today is deploy 100 VMs in about 5 minutes or so, give or take. And for this demo,
that's a good goal.
Yeah, yeah. Normally it happens within 5 minutes, might be a little longer. On the right side of the screen, you'll see a simple chart. And basically what this does, it's just got like a web server running, and the VMs that I deploy are going to make web requests to the server. And as they do that, the graph is going to show us the number of unique entities that are making requests. And I can do this also from my laptop. So if I do this now, you'll see, let's say that there's one VM. Of course, it's not actually a VM, but that's the general idea. And after 10 seconds or so, it will time out and go back to 0. So these VMs have to be constantly communicating to be counted. And then once they...
So it sends a signal one.
Yeah, it continues to do so in a loop. So
Right.
the VM is running just a very basic flist that just contains a shell script that just makes requests to the server that's running on my machine right now. So it's kind of a toy example, but you might, in a real setting, you might want to use TFROBOT for something like load testing your system. So you might want to have VMs in a number of different locations, all making connections and testing that your infrastructure can handle load. So that would be sort of a similar application to what we're doing today. And so inside my folder here is a box where I'm looking at beautiful faces, but inside the folder here, I have actually an output.yaml from the last time I did this. I'm going to go ahead and remove that. So we'll get to that later, but I have a config.yaml and a config.secret.yaml. These are the same file, the only difference being that the one secret has this my seed phrase inside that we're using for deployment. You put that directly into the config file. The other one is the sanitized version that I'll be showing to you. So what I want to go ahead and do now is just kick off the deployment, and as it's running, I will give you a tour of the config file, show you what's in there so we can get these things running in parallel. To create the deployment, this is very simple. Just write TFROBOT deploy. I'm going to pass C for config and give it the path to the config file. In this case, the one with the secret, so it'll actually work. And once I do this, TFROBOT will start doing its thing. It's opening up an R&B session, checking the config file. It's looking for nodes, and it's going to start making deployments. So while that's working, I will show you here. Yeah. In, another tab, let's look inside of this config.yaml. About the secret. Let's see if I can do this over here.
Yeah, we see well.
Cool. So if all goes well, we should start to see some VMs popping up on the right. So that'll keep you entertained while we walk through while we go through the boring part here, what's inside this config file. So we have first our node groups. You can create multiple groups. In this example, I am just doing a single group, call it group A. That's coming from the big example. Node count, how many nodes we want. In this case, we are deploying to 20 nodes. So 100 VMs on 20 nodes, it's going to be 5 VMs per node. These counts are how much free capacity we want these nodes to have. So in this case, I'm looking for nodes that have 2 free logical cores, 16 free gigs of RAM, 100 free gigs of SSD. Since CPUs can be over provisioned, 2 is fine here, but maybe since we know there's going to be 5 VMs per node, maybe we want to change this to 5. Anyway, this allows you to find nodes that have certain characteristics, in this case, a certain amount of free capacity. We can also find nodes, there we go, some VMs are popping up, that's nice.
Oh yeah.
We can also find,
Almost 20.
yeah, it's happening fast. It's usually the last few that take some time, so. Walking through the config file here. We can also check if the nodes are dedicated. To be honest, I'm not sure why this is in here. We wouldn't probably be using this to rent dedicated nodes, but maybe you could be deploying to your own dedicated nodes. I'm not sure. We can also check for public IP4 and IPv6. In this case, I've set public IPv4 to true because I wanted to find some certified nodes in some of our gold certified farms. So I'm looking for certified nodes, also public IPv4. It's just a nice way to find some highly reliable nodes. I found if you go into the general pool of nodes, you'll have more failures and retries. Eventually, you'll get to where you're looking for with the number of deployments. Also check for nodes that have IPv6. In this case, we don't care. We can select the regions. Here we're deploying to Europe because this is where most of our nodes are. Most of our certified nodes anyway. Nodes in the US. Not sure how that stacks up. And a lot of nodes in Canada too. Thanks, Meek. Down below we have our VM groups. So again, we can have multiple groups of VMs. Then give these a name. In this case, we're just using one. So each VM group goes onto a node group. So you can see how you could use this to create more complex arrangements where you maybe have 5 node groups and 10 VM groups and these.
And you can use different F-lists.
Yeah, so each VM group is using one F-list and one set of environment variables as well. So that's the main constraint here is that our VMs are basically generic, they all follow the same template. So these are going to have one CPU core, there's 250 gigs of RAM, which you can give as a fraction of a gigabyte. No public IPv4 or IPv6, just an drizzle IP, which even technically we don't need, but if I didn't put this, then TFROBOT is going to assign it anyway and print a bunch of logs, extra logs. So that's just there to suppress those basically. The F-list is one that I made. It's just a very simple Alpine Linux with the shell script inside. Entry point, we run the shell script, and that's what's creating these network requests coming to my machine. We have a bit of magic in the middle with an SSH tunnel, and just the request can get in. And finally, we have an SSH key. This is not strictly necessary because we actually don't have SSH running inside this VM. But TFROBOT might want this anyway. I'm actually not sure about that. So anyway, you can put multiple SSH keys into this list here, and then you can choose among them for your VM groups. So again, if you want multiple VM groups, multiple SSH keys, you can do that. And lastly, we have some environment variables. So this, for the example, is the IP address that our VMs are going to connect to that ultimately connects to the app that's generating the bar you see on the right side of the screen. And we connect to a certain port and we have some other parameters. These are just part of this deployment for the example. Finally, we have some global configs. So this is your mnemonic. You're going to put your secret words here. In this case, we have mainnet and max retries for each node group. This is the default of 5. Again, if you're going on DIY nodes and sort of more Wild West, you might need more retries.
Yeah.
Typically, I think 5 would be okay. It'll just take a bit more time.
What happens after 5, let's say?
If it can't successfully create all the deployments, it will tear them down and just you'll return back to the original state of wherever you were before you started.
Okay.
So
we see that it works here. You reach the 100 node.
Here we've managed to deploy 100 VMs on 20 different nodes across the grid. So let's check now. We have an output.yaml, and actually if I go back to my first terminal window, this is the same. It's going to print it to the screen, but I can also look in here and this will show us all of the OK groups. I guess if we had a failure, maybe there would be like a not OK piece in here. This shows us, so these are all of our VMs, and for each one, we would have the IP addresses, the node ID, contract ID, and you'll notice that these are in groups. So for this node, These are kind of hard to read because they're all squished together. But node 428 is going to have VM 69, 89, 49, 19, 29. So that's how TFROBOT is constructing the groups, is for each VM, in this case, it will be, or for each node, it will be VM numbers ending in 9 will belong to the same node, or half of them belong to one node, to another node. Let's just detail about how these are grouped together. So this is where we can see all of our resulting VMs. So that's cool. We have all the info in there if we needed to do anything more with that. And now we can go ahead and cancel these deployments and see how quickly that went. So the TFROBOT cancel. So it's the same form. We just write cancel instead of deploy it. Give it our config file, and it will start to tear down these VMs, and we should start to see them.
This time, I guess it took less than 5 minutes even to deploy the 100 nodes.
We did it in 3 minutes and 4 seconds. So that is exceeding expectations today.
That's massive.
And here we go. We are canceling these VMs. That happens pretty fast.
Yeah, even quicker. Can you see how long it takes, or you have the cancellation? It's just so quick. We don't even need it.
Yeah, it doesn't give you any indication of how much time it takes to cancel them. But as you see, it just takes a few seconds. So I guess this is our last slide here. So I'll go ahead and stop the share. We can open it up for questions.
Well done.
Questions or comments? Thank you.
Any questions?
My first question would be, what would you use this for?
That's a great question. So like I mentioned, like load testing some infrastructure might be one. Beyond that,
It's up to the deployer, I guess.
Yeah, that's for the user to decide. I'm fairly sure that this tool was actually developed though to help us to test the grid. So we've been testing that you can deploy thousands of VMs actually. It takes,
you can test the whole grid actually, I guess. You can just deploy on how many nodes are there? Okay, deploy on all of them.
Yeah, you can try to deploy on all the nodes on the grid. So that's another potential use case.
But after if you've seen, you can have them in groups. So let's say you have different F lists. You can even have, let's say you want a big architecture on 100 nodes, and you need 3 different programs. So each of them can run a different F list. So you can build your own F list with all the steps, and then you can make sure that the VMs connect together if it's needed. So really, it's up to the architect, let's say, of the product they're designing, or the end goal of let's say the application you want to have. Because I guess once you have different groups of F list, they can have each different goals. So let's say you have a website that needs 3 subdomains. You can have all of them separately, or just some ideas, but it's really it opens the door to a lot of flexibility.
But then you would still deploy the website, the subdomains on each VM, right? I mean, it's still. What I was thinking is, I've not seen the QSFS demonstration you give, but I was thinking that maybe this goes sort of the same way, that you can actually deploy something to group VMs 8 and it spreads it out over all those VMs, but it doesn't work like that then.
But I guess there's some you can play with it. You could have an F list that deploys a quantum file system, and then you have a 10 different deployment or 100 deployment with this F list. So and once you have this, you have the configuration file that Scott showed. So I guess after this, you can use it. You can use the information because you have all the IP address, and if you need to, you can automate other processes.
Okay.
One fairly common use case is you have like web application has database, and then you have one or more web servers sitting in front, right? That accept incoming user connections and talk database. So this could be a way to build up a group of web servers that are sitting between your users and your databases. in a typical cloud environment, you would have like a load balancer provided from cloud provider in front of that. In our case, you could use a gateway. I think we have a basic load balancing feature in there already. So you can have traffic coming into the gateway and it's being distributed among, say, 3 web servers, again, to handle a large amount of traffic. And so this would be a simple way to provision those machines based on an F list that takes some environment variables, spins up a web server, and then you could scale those up and down as needed. That's another like potential use case, anywhere that you would need a number of sort of identical cookie cutter VMs. We're also looking at building a solution for like continuous integration, continuous deployment pipelines. There might be another one where like if you needed to create some worker nodes for any kind of like data processing.
Yeah. Could you try, let's say,
well.
you have 15 pre-search nodes and they all have their own F-list. Basically, you made one F-list that has all the parameters for each, and then each of them have the different environment variables. Would that work? You need
yeah.
for each, or
yeah. I think if you pass in you have like your secret that you would pass in as the environment variable, and those could all spin up.
Yep.
Yeah, it's possible. It might be complicated with pre-search because they require a unique public IPv4 per deployment, but that's in general a good point. Like if you had some sort of like Web3 node like this that you wanted to deploy multiple copies of, be a way to do that.
Or even just something to store information. Let's say you have a website people can connect and store information, but you have the deployment at after 5 nodes that are full. Let's say their storage is full, then you deploy something else, some more nodes.
Yeah, it could be. You might at that point you might be getting into territory where you would need some scripting, but actually you could even combine, like TFROBOT could be used along with scripts, right? Like you could easily generate these YAML files with some scripts or code. So that's a potential use case as well.
What would you do, Robert? Do you have an idea with this tool?
No, not yet, but then again, I'm not much of a scripter or technical. I mean, everything I learn is actually I'm learning it from you while I'm doing it, you know. So I'm trying to find out how I can use this. What you were just saying, it might be interesting. One of the things that I found very hard is to scale VMs, but I don't think this is the solution for it. Well, unless I'm wrong, but you know, I started a web.
What would you want to do? Let's say with.
Well, I started a web server, for instance, a web hosting server. I used virtual min, and I actually got it to work. It took me, well, you know, I have to do it next to my job, so it took me months, not all at once, but eventually I got even the mail server up and running and scored 10 out of 10 currently. So it doesn't end up in spam anymore. I'm really satisfied with it.
Wow, nice.
But then, you know, I made it like 100 gig. And then I figured I can have 25 gig customers on it. And then what if customer 21 comes? What am I going to do? You understand? So I find it hard to scale that, you know.
Yeah.
So
if you could turn it into an F-list, like with all the steps, what you did, and then you could use it to mass deploy, actually. But at this point, you could just, if you have, let's say, one F-list that can handle like 5 customers, and then you can just deploy another one if you need for the 5 next customer. But then if you have a huge number, then you could use the mass deployment of the TFROBOT. But it would be like an additional step, how I see it, because we're like the base, we're working with the F-list for the mass deployment, right, Scott? Like each TFROBOT, they're using F-list, basically.
Yeah, I think for Robert's use case, it's maybe not, doesn't work as well because this is a setup where you have a public IP and a domain that are pointed to this particular machine. So it's not ideal, right, to need to provision additional public IPs and additional domains or subdomains to scale up.
There was a way in virtual min to cluster other virtual min instances. Well, they call it there's virtual min and there's virtual admin or something. I mean, there's two different, you know, and you can have actually multiple one inside the other. So, but I don't know if that would work with, you know, IPv6 addresses or so. I don't know. I've not tried it.
But imagine you make some tests, you make an F list that sends an email to your server, and then you deploy 1,000 nodes, and they all send an email at the same time. Then you can test if you're able to tolerate this. If your web server is okay with taking in thousands of demand at the same time.
Yeah, I think the load testing use case is a good one. And for this, like for scaling VMs, we are working on some additional features in ZOS that will make this more simple, particularly snapshots. I mean, this would allow the user to just make a copy of everything that's inside of their VM, destroy the one that they have, and then restore that into a new VM with new specs.
Yeah, there was one other feature that Drew taught me, and I think I used it more than a year ago, so I'll have to look it up. And it works with groups instead of oh, how do you call it? You don't what do you use the word? You don't use disk space, but what did you just call it?
There's snapshots.
No. Instead of in Linux language, a disk space is called what? You have groups and you have what do you call it?
The volumes, perhaps?
Yeah, volumes. Yeah, they call it volume groups, I believe they call it. So then you can actually, if you start off with a volume group, and inside the volume group you create your first volume of 100 gig, and then later you find out it's not enough, you can actually create a second volume in the same group and then somehow mount them together, and it doubles the space. I managed to do it once, I think using Terraform or yeah, I think so. So there's a way of doing it, but it wasn't easy.
Yeah, so with Terraform, you can currently do a lot more. You can actually scale if your VMs are created with disks, we call them, and sometimes we use these terms interchangeably, but on the grid we have disks that can be attached to VMs, and so the full VMs are using their root file system as a disk, whereas the micro VMs are doing something else, let's say. So if you have a full VM in the current architecture, you can detach that disk from the VM, which is your compute, you know, that's your CPUs and your RAM essentially, and you can split that off from the disk and then bring back a larger VM and attach that disk and boot it up, just like taking the hard drive out of one machine and putting it into another. You can also add additional disks to a VM that is currently running. I don't know if you can scale the disks, but you can use some, let's say, fancy footwork. Like you could bring up a bigger disk, copy all the files into that one, and then boot from that disk the other time. Like inside Terraform, you do have more flexibility in terms of how you're working with the VMs, especially if they are full VMs or if they are micro VMs where you're using the disk. You know, all of your data goes onto the disk, and then the micro VM F list has all the applications inside of it. That can be another way. So there's some things you can do like that today. They require that you use Terraform from the start, or that you do something more advanced. Like at one point I developed this recovery tool because we're having some things like kernel crashes.
That was nice. Could be a template for some more project.
Yeah, so it is possible, like if you have a deployment that was created in the playground, if you have the right tool, you could come back and do some of these more advanced things with it. And or maybe one day those sorts of features will be built into the playground dashboard as well. But yeah, for now, if you want the best flexibility, Terraform is really the way to go. And yeah, you can attach additional disks later, and as long as your software is able to use those, then that should be fun.
Is it just the four of us right now, or yeah, I believe it is or not?
Yeah, small group today.
Would that be a good demo? The recovery tool, maybe some variations, some basic stuff.
Yeah, we could show how this works in Terraform. That might be nice just to see.
Yeah, we didn't explore Terraform so far, so that could be a good introduction too. It went well. was fun to see it work because we reached the lucky number 100. That was great. Very quick, actually, 3 minutes. So good work, Scott.
Thanks, Mick. Thanks for your help today.